us now take up what is a dimension of a physical quantity. Let us just consider this dimension part. What is this dimension by definition? It is the power to which a fundamental unit is to be raised to obtain a derived unit. We can even tell the same thing this way also. It is that power to which a fundamental physical quantity is to be raised to obtain a derived physical quantity. Just now, of course, we have discussed a few examples. Out of them, I just have given area. Area, we can write this one as length square. When I write this area, we know that this is a derived quantity. Length square, while writing towards my right, length being a fundamental quantity, when I am raising this one to its second power, I am getting area. That is a basic concept one can understand by looking to this equation. Then what I can write from this? The dimension of length in area is equal to 2, I can write. What is the dimension I said just now? It is the power to which a fundamental quantity is to be raised to obtain a derived physical quantity. In other words, it is the power to which a fundamental unit is to be raised to obtain a derived unit. When we consider length as fundamental and when I am raising this one to its second power, I am getting area there. So what one should understand out of that one? First thing is, area simply depends on length alone, not on any other thing like. Any other means what? It is independent of mass. Area does not depend on mass. So if at all I want to write mass along with this length square, I should represent this one as mass to the power 0. According to mathematics, anything to the power 0 is 1. Similarly, when I just mention the third physical quantity which is fundamental as time, this even is not depending on time, therefore I can write even its power as 0. So if I write area is equal to length square into mass to the power 0 into time to the power 0, suppose if I write like that, then I can conclude dimension of length in area is equal to 2. Similarly, dimension of mass in area is equal to 0. Similarly, dimension of time in area is equal to 0. The moment we are accepting the fact that the dimension of mass is 0, time is 0, it's very clear to say this particular quantity area is independent of mass and time. It only depends on length. Therefore, we can say the power to which we are raising the fundamental quantity or the unit to obtain either a derived quantity or the corresponding unit of that, that is what we call it as a dimension. Therefore, dimension of length in area is taken to be 2, and for mass and time the dimensions are taken as zeros. Likewise, let us consider one more. Let us say velocity. Velocity, when I write, it is displacement by time. That is the basic equation. Rate of displacement of the body. We can even write mathematically ds by dt. When displacement is differentiated with respect to time, we will be getting the corresponding value of velocity there. So when I write this one in the form of an equation, s by t I can write. So when velocity is equal to s by t, s can be written in terms of length. Every one of us can understand rather, distance or displacement can be measured in terms of length there. Length is a fundamental quantity. So we can write this one as length to the power 1. This is by time. I can bring this time term to the numerator, writing that one as time inverse. So we can understand here length to the power 1, time to the power minus 1. Then how to represent the dimensions in this particular equation? You can say dimension of length in velocity. What is this dimension of length in velocity now? It's 1, the power of length. Similarly, dimension of time in velocity, that should be taken minus 1. But in this particular equation, if you carefully observe, there is no mass term in that. When mass term is not there means it is understood the dimension of mass in velocity will be 0. That means velocity of any body for that matter is not going to depend on its mass. It is independent of the mass of the body. That is what you can conclude from this description as such. So this is the method of identifying what is the dimension of the physical quantity taken up. But dimension alone will not be sufficient for us. We need to write what are the dimensional formulae we have for different physical quantities. So for example, when I just write what is dimensional formula? What is this dimensional formula? Dimensional formula, when you talk about, there are 3 fundamental quantities mainly for us taken from general mechanics: length, mass and time. If you take length, the dimensional formula for length is taken as capital letter L. When we consider the second one as mass, the dimensional formula is considered as capital M. When we take the third fundamental quantity as a time, the dimensional formula for time has been mentioned as capital letter T. So whenever we write a dimensional formulae for different physical quantities, we need to use these 3 letters: capital L for length, capital M for mass and capital T for time corresponding to that. Now while writing dimensional formulae in terms of length, mass and time of any physical quantity, there are mainly 3 conditions we need to remember. What is the very first condition? All the 3 letters are to be written only in capitals. That means while writing dimensional formula, you are not supposed to write any small letter over there for length, mass and time. So all the letters either L or M or T should be written in capitals. That is the first condition. What is the second condition over here? All the letters are to be written only in the numerator. Only in the numerator in the sense what? Negative powers are taken up. That means you can have negative power for any physical quantity. They are acceptable. So what we can understand in this case, the first one you should write all the 3 in capitals. Okay. Second one, you should write every letter in the numerator only. That means negative powers can be acceptable. That means you can understand, for example, speed or velocity we have. When I write velocity, it is length to the power 1, time inverse. That is the dimension actually what we have written. Dimension of length is 1, dimension of time is minus 1. Suppose if I want to write dimensional formula for this, it should be written LT inverse. For length it is L. For time it is capital T. time inverse we have, therefore I can write LT inverse over there. But come to the third condition. Whichever physical quantity you are taking up and writing the dimensional formula corresponding to that. While writing dimensional formulae, we need to write all the three letters like M, L and T. Whether that quantity is depending on mass or not, length or not, or time or not, whether it depends on all the three or any two, or sometimes it depends only on one quantity out of the three. But whatever be the case, while writing dimensional formula, we need to write all the three letters over there. That is a correct way of representation of dimensional formula for a physical quantity. For example, when I take this velocity, if I write LT inverse, that is not that correct. So what is the correct way of representation? M0 L T inverse. M to the power 0, that gives that its value is 1. Ultimately it comes to be LT inverse only, but this is the correct way of representation as far as the dimensional formula of a physical quantity that is concerned. And how to write a dimensional formula if at all you take up that matter? You need to know what is the corresponding formula for that quantity. When you know the formula, automatically you can write the corresponding dimensional formula for that. Let me just explain you few physical quantities with their dimensional formulae. How to just write those dimensional formulae for such physical quantities as such, considering their corresponding formulae. Let us write dimensional formulae for few physical quantities, so that we will be able to understand how to write the dimensional formula for a given physical quantity as such. Let us start this way. I take, say, density. Density by formula, it's mass by volume. Then we can rewrite the same this way: mass divided by length cube I can write. This volume, of course, in terms of the fundamental quantity as length, I can write it as length cube. Then what would be its dimensional formula? M L power minus 3. Since time it is not in this particular equation, it is understood density is independent of time. But still we can write that one as T power 0. This is the correct way of representing the dimensional formula for density. Exactly in the same manner, when we talk about force, general formula is mass into acceleration. We can rewrite the same this way: mass into acceleration is change in velocity by time. But again, velocity is displacement by time. So I can write this one like this as length by time square. Velocity by time is acceleration, displacement by time is velocity. So overall length by time square. How can we rewrite this one again? Mass into length into time to the power minus 2. Therefore we can write M L T power minus 2. This is the basic way or the method of writing dimensional formulae of different physical quantities. But in reality, no need for anyone to go to that basic. When you are aware of all these formulae, writing dimensional formula would be very, very simple and easy. For example, when I consider this work done, work by formula is force into displacement. Now I can write ml square T power minus 2, that is a dimensional formula for work. Similarly, when I just consider the concept of power, its rate of doing work, it is W by T. I now can write that one ml square T power minus 3. Similarly, one more, let us take this one is universal gravitational constant. Universal gravitational constant, we represent that one by this capital G. What is the formula generally? Fd square by m1 m2. According to Newton's law of gravitation, gravitational force of attraction between any two bodies having masses m1 and m2, which are separated by a distance d between their centers, that we can write it as F is equal to G m1 m2 by d square. From that formula, I can write G as Fd square by m1 m2. Then what would be its dimensional formula now? M inverse L cube T power minus 2. That is the dimensional formula for that universal gravitational constant. Likewise, when we consider like Planck's constant, in reality, Planck's constant we come across in the concept called photon energy. The energy of a photon we can write as h nu. H is going to be Planck's constant here, and nu refers to the corresponding frequency. So how can we rewrite this one now? H can be written as energy by frequency, but reciprocal of frequency is called as a time period. Therefore, I can even rewrite that one in this form, that is energy into time. Already we know what is work. Work and energy both have the same dimensional formula. So ml square T power minus 2 into T. So what can we write now? It can be ml square T raised to the power minus 1. That is the dimensional formula for Planck's constant. But same Planck's constant, whatever the dimensional formula we have written, that has got same dimensions of angular momentum also. What is this angular momentum? Let us take one more example here. Angular momentum. When we write this angular momentum as L, the general formula for this one is mvr. M for mass, V for velocity, R for the radius of that circular orbit. So what we can write now in this case again, mass is capital M, velocity LT inverse into L. Once again you be getting ml square T inverse. That is the dimensional formula for this angular momentum. See carefully what is the dimensional formula we have written for Planck's constant and what we have written for angular momentum. This is ml square T inverse, that also is ml square T inverse. That means what we can conclude from these two? Angular momentum and Planck's constant both have the same dimensional formula. What is the corresponding dimensional formula here? M L square T inverse. That is the concept now. So similarly, there are few physical quantities which are having similar dimensions or dimensional formulae with respect to some other physical quantities. Let me just give you few examples for that. Let us now take up few physical quantities which have identical dimensional formulae of a few other physical quantities. Like, I just give you few sets of quantities here. One is speed and velocity. In reality, what is the major difference between these two? Every one of us can understand. Speed is a scalar quantity, not having direction. And velocity depends on direction as well along with magnitude, therefore it is to be called as a vector quantity. So speed and velocity, when we take, the dimensional formula is m0 L T inverse. Both have the same dimensional formula. Likewise, when I take one more, like acceleration and gravitational field strength. Gravitational field strength. You can even call the same as gravitational field intensity. What is acceleration? We all know. Directly we can write it as rate of change of velocity of the body, dv by dt. And gravitational field strength can be defined as the gravitational force experienced by unit mass at that place. So we can directly write both have the same dimensional formula, L T raised to the power minus 2. So acceleration, whether you call it, retardation you can call it, deceleration you can call it, acceleration due to gravity you can take, gravitational field strength or field intensity we can consider. All these physical quantities have got the same dimensional formula, that is m0 L power 1 T power minus 2. That is the dimensional formula for it. Similarly, one more let us consider here, that is linear momentum. Linear momentum and impulse. This linear momentum and impulse, linear momentum, what is the formula? Mass into velocity. And what is impulse formula here? Impulse is nothing other than force into time. There is another way of representing this impulse. It is also called as change in angular momentum. Sorry, change in linear momentum. Change in linear momentum and linear momentum both will have the same dimensional formula. So what we can write here? It is m L T inverse. So impulse, we can repeat that one, like impulse is equal to force into time, one formula. Change in linear momentum is the other formula. Whichever one you take up, ultimately you will find that both linear momentum and impulse are having the same dimensions. That in the sense m L T inverse will now be the dimensional formula for it. Similarly, when we consider one more, like work done, then energy, then the quantity like torque, they are all going to have the same dimensional formula, ml square T power minus 2. That is the dimensional formula for it. Once again, what is the difference between them? Work done is a scalar quantity. Energy also is a scalar quantity. But torque will be a vector quantity. So work done, when we talk about, it is force into displacement. Energy is nothing other than the capacity to do work. That has got the same formula, same units, same dimensional formula like work done. Not only that, torque, when we consider, it is force into perpendicular distance. We can call it R cross F. We write as the formula for that. RF sin theta is its equation, and it is a vector quantity having the same dimensional formula of work done. Another thing let us take up in this case, that is angular momentum. Angular momentum, this has got same dimensions like Planck's constant. Angular momentum has got the same dimensions like Planck's constant. What is the dimensional formula? ml square T inverse. In fact, you need not simplify to get that one and all. Recollect Bohr's postulates. According to one of the postulates mentioned by Bohr, to give that concept of hydrogen atomic model, one can understand that angular momentum of an electron in an orbit is an integral multiple of h by 2 pi. So even if you can remember that angular momentum, we write that one as mvr, that is n into h by 2 pi. So n being a constant, that of course gives you the principal quantum number. N is 1 means first orbit, 2 means second orbit, and so on and so forth. This 2 pi being a constant here, mvr and h both will have the same dimensional formula. So we can understand that angular momentum along with Planck's constant do have the same dimensional formula, which is ml square T power minus 1 as such.